Can you see my screen?
Yeah, I started recording.
Okay, one sec.
Mega
Okay.
PDFs.
Right. Let's do this.
Yo, how long's your session for today, Slater?
Hours today.
Sorry?
2 hours.
2 hours?
Yeah.
Jeez. Okay. Yes.
Alright, so the chapter 5 and 6 set it's just one set of problems. There's like 10 problems for both of those. So the first one's pretty simple. I guess I'll just skip that. We'll start with the second one. Okay, so let me highlight the important stuff here. The city of Atlanta is considering adding new buses for its current mass transit system that links from the Hartsfield International Airport to Peter City. Okay, I'll leave this. The total capital investment package is worth $12 million and is expected to last 8 years with $1 million salvage value. Annual operating and maintenance cost is $2.5 million and growing annually 8%. 500,000 trips per year. We wanted us to find the charge per trip. All right, and 8% interest rate. So this we know that the MAR. Okay. MAR is 8%. That's the final line that was there. Yeah. Now it's 500,000 trips. Let me draw the cash flow diagram for this. $2 million investment. And it's 8 years. Okay. Next. $1 million salvage value. Annual costs are 2.5 million and they increase by 8% every year. 0.5 million. And we can do this geometric gradient that has a G of percent, right? Okay. Else 500,000 trips, that's done. Define the cost per trip. Okay. Yeah. So I guess that's it. Now what we do for this one is we need to find the annual equivalent cost of this entire system, everything included. And then we divide that by 500,000 to find the cost per trip per year. Okay. There are 500,000 trips per year. Okay, so to find this annual equivalent cost, it's 12 million in the first one, plus, I'm not gonna write million, plus 0.5. We use the formula for the geometric gradient. In P given A1, that we have G equals to 8% and I equals to 8%. Okay, you guys can see my stream fine, right?
Yeah.
Or is it really blurry?
No, it's good.
Okay, cool. So
And
this is what we use. Sorry?
You forgot the N.
Right. Yeah, not bad. So N is going to be 8 because there's 8 years, and then minus 1 million, which we're going to take back. See, it's in the 8th period now. We're going to take it back to V0. So we're going to do find P given F, that 8% MAR, and 8 years, right? Yeah. So to do this, 12. Okay, now for the formula for the right here, we can see the formula for the geometric gradient is this one, but then if I equals to j, we use a smaller one. And in our case, the I is equal to j, so 12 plus 2.5, and p, okay, and so the formula is 8 divided by 1 plus 0.8. And minus p given f. Alright, we can just do that. 1 into 1.08 is 8. So when I solve this, I get 12 plus 0.5 into 8 divided by 2.8 minus 1.08 raised. This is not 0.8, it's 0.08. Minus 8. Let me 1 second. Think this is 29 million. Am I wrong? Let me check if this was right with chapter 5. Second. This is a different question. The second question. What did I do here? Million. Right, we need to find the annual cost. This is the present cost, right?
So the A
This
given
would,
P.
yeah. So now you find A given P percent years. This wasn't 29, just it was 29.97824. That's million. Okay, AP 8. You can find this from the interest tables. Percent.
Wait, so
Here.
hey, do you not have my Excel?
Excel what?
It's an Excel calculator for.
Oh, right. No, I don't remember where it is.
Oh crap. Okay, if you want, I can send it because it'll speed up the process for chapter 5.
Yeah, sure. Okay.
Alright, I'll just send it in chat. You can continue though.
So for this one at least, I'll just do this AP 8%. This is 8%, right? That is 8% and 0.174. 0.174. Is that right? Yeah. 29.97824 into 0.174. 0.21613 million. This is the annual cost. But we need the cost for, and there are 500,000 trips in a year. Let the cost per trip be C. So 500,000 to C is going to give you 516,213 million. I mean, 0. Okay. C equals to 216,213 divided by 500,000, which is 10.43. Let me check if that's the answer. Right. It's chapter 5. Yeah, so the answer for 2 3 there is the cost per trip. So does anyone have any questions on this one? What we did is we found the annual equivalent cost of this entire system. Then we divided that by 500,000 because there's 500,000 trips per year. Get the cost per trip per year. Dollars per trip per year. Okay. Yes. So any questions? Right then. Yes, I'll move ahead. Number 3. Should we do question number 3 or? Let me check. Yeah, let's do 3 and skip. Okay, I'll do question 3. No. What just happened? 1 second. Okay. Number 3. So in this one, they gave us 2 different products and they gave us cash flows for that. So right here, for product A, the third revenue is given as X. We need to find what the revenue is going to be. Solve for X. And it's saying that the product should have a 30% internal rate of return. The way we solve for internal rate of return is that two methods. If it is a simple cash flow, I'll tell you what the simple cash flow means. If it's a simple cash flow, you use the net present worth method. You find out the net present worth of the entire cash flow, and you equate that to 0. If it's non-simple, you do is you find the project balance. We'll do a question of this too later on. Find the project balance at the end of the cash flow, and you equate that to 0. So here, what simple cash flow means is that if you see only the first one, only the first value is negative, and all the others have the same sign, all the others have positive. So this is a simple one. Non-simple one would be, right here. This one, see it's negative at first, then it's positive, and again negative. So if the sign keeps changing, that's a non-simple cash flow. And in that one, to find the internal rate of return, in this one, you use the project balance method. But in this one, it's just normal net present worth. So to do this, we need to find net present worth equal to 0. What we do for this is the first period has negative 100,000. Then plus 70,000. But we need to take this back to V0. So 1 plus I raised to the power minus 1. And I is 3%, if I'm not wrong, right? Internal rate of return, yeah. So you can just write 1.3 raised to the power minus 1 and plus 60,000 in period 2. So you take it back 2 years. 1.3 raised to the power minus 2. X is the value that we need to find. 1.3, and you take this back 3 periods. Okay. This is just maths. After this, you just take it to the other side, take the 100,000 to the other side. X into 1.3 raised to the power minus 3 is going to be 100k minus 70 and 1.3 raised to the power minus 1 minus 60k 1.3 minus 2. Now, let me just solve this. 100,000 minus 70,000 to 1.3 minus 1 minus 60,000 1.3 to the minus 2. Yeah, I got this as 10650.8876. Now you take this 1.3 on here, 1.3 to the power minus 3. So you can just take it to the numerator, and it'll become 1.3 to the power 3 to 1.3 to the power 3. Get this as 23,400. Let me check if that's right. Yeah, but it's the third one is 23,400. That's how you solve for X. In the cash flow. Anyone has any questions in this? The way we found net present worth is just what we used to do in chapter 3, just bringing it all to V0, 0th period. That's all you do. You take it back 1 period, take it back 2 periods, take it back 3 periods. Then you just rearrange the equation and you get it. Alright, so if there's no questions, I'll move ahead. Question number 4. So now they tell us to use X equal to 147,000 instead of what you found. So our cash flow would be N0, 1, 2, 3. A, it would be negative 100,000, 70,000, and 60,000. Then 147,000. Okay, and this is still a simple cash flow because there's only negative ones in the starting, and then it's all positive. Now, what they tell us to find is the incremental investment, the IRR for the incremental investment. What the incremental investment means is that after you write down for both A and B, for B it is 100,000, 60,000, 120,000, 90,000. What you do to find the incremental investment is that take B minus A, right? And actually, no, in this case, we'll be taking A minus B. So what you need to do is you need to subtract A, you need to subtract B from A. So in the first case, you get 0. In the second one, never mind, it was B minus A. You get negative 10,000. Then you get 120,000 minus 60,000 as 60,000. 8,000 minus 147,000. You do what this is. You get a 57,000. Okay. So the reason I took B minus A and not A minus B is because you need to just check that the first non-zero term in your incremental investment column be a negative. If I would have taken A minus B, it would be 0 and then 10,000. And we cannot have that. It needs to be a negative in the first one. Okay. Now, if you see this column, the B minus A, this is what we'll be using to find the incremental investments IRR. In this case, there's a negative first, a positive, and then a negative. This is a non-simple cash flow. So for the non-simple cash flows, we use the project balance method. Project balance at the third period is equal to 0 is what we need to do. So the way we find the project balance is you start from the 0th period. You take each cash flow into account. So the cash flow diagram for this B minus A would look something like this. 0, 1. There's nothing at the 0th period. In the first period, it's negative 10,000. In the second one, so it's going to get like this. And in the second one, there's like a 60K revenue. So 60K. Then it's going to get affected by MAR. I'll talk about that. So then there's a negative 57,000. Negative 57K. What happens in this is that there's two different interest rates being taken into consideration in this. Right here, when it's always below, it's going to be the I they gave us. They didn't give this to us. They told us to find this I, the incremental rate of return. And here on top, the MAR is going to be used. And the MAR is given to us as 20% right here. Okay. So what we're going to do for this is project balance at 0 equals to 0 because there's nothing. Project balance at 1 is equals to minus 10K. Right? Project balance at 2, the minus 10K gets affected by the I. We need to take that. So minus 10K. And we are taking it forward by 1 period. We're taking this minus 10K forward by 1 period. So what you do is 1 plus I raised to the power 1. And then in the second period, there's a 60K revenue. This one. Right? So to take that into account, we add 60K. Okay, this is the project balance at the end of the second period. The project balance at the end of the third period, this whole thing is going to get affected by the MAR and not the IRR. What you do for this is minus 10K, 1 plus I, 60. This whole amount, we need to take it forward to the third period. So to do this, we're going to take it by using the MAR. So the MAR was 3%. This was given to us in the question. So 1.2 and raised to the power 1 because we're just taking forward by 1 period. So raised to the power 1. Next, there's this 57K in the third period. Minus 57K. That's pretty much it. So we know for the project balance method, the PBN, the final project balance in the final period has to be 0. So PB3 has to be 0 equals to minus 10K, 1 plus I, 60 into 1.2 minus 57. Now we just need to solve for I. It's again just rearranging the equation. So you get 1 plus I equals to 57 divided by 1.2 minus 60 divided by minus 10. I'm just rearranging this equation. And then you can simplify it even further if you just take this I, the 1 goes to the other side. This is we just need to solve for this now. 57 divided by 1.2 minus 60 divided by minus 10 minus 1. So you get 0.25. I is 0.25, or you can write that as 25%. The IRR in this case, the incremental of return in this case, is 25%. So what this means is that how we use this is if the incremental IRR is greater than the MAR, choose the second project. Whatever you're taking in this B minus A, whatever is the first thing you're taking is what you'll choose if the IRR is greater than the MAR. If the IRR is less than the MAR, then you choose project A. In this case, IRR was 25%. The incremental IRR, okay, it was 25%, and the MAR is 20%. In this case, choose B. He didn't ask this to us in this question, but he could ask this to us in any other question. This is all you need to do for that. After you calculate the incremental IRR, you just need to compare it with the MAR. Again, you're choosing B here because that's what you took as your first term in this B minus A. If you would take A minus B and you would get the same 25% IRR, then you would choose A. That's pretty much it for this one. They asked us to find the incremental investment, and the answer is 25%. If we go here, 25%. Okay, so we're done with this. Anyone has any doubts in this one? What we did is we found the incremental investment, this B minus A column. Then I just drew this cash flow diagram to help you guys understand when the I would be used and when the MAR would be used. Then we found the project balance in each of the different periods, arranged the equation, and we got I. So you guys can ask any questions if you have now. Right, then I guess I'll just continue. Okay, should we do this one? Could do this one, but then that's good. Right, let's do the 7, 8, 9, 10, and we'll come back to the 5th one if we have time. 7th. The following table provides cost and unit sales projections for a firm. So first thing to notice here is all of this is the cost. All of this is the revenue that they're getting. Revenue isn't given to us. All they gave is they sold 50,000 units in the first year, 70,000 units in the second year, and 100,000 units in the third year. So, disconnected, or can you guys still hear me?
It's cutting out a little bit, so maybe just do the stuff a little bit slower, but it's fine otherwise.
Oh, is my audio cutting out, or is it the screen?
It's like kind of both. Like basically, like if you say a word, sometimes it just slows down a bit.
Oh, damn.
I mean, you can't really do anything. It's fine.
Yeah. Okay, I guess we'll just continue. Okay.
Just maybe slow down on your
gave-
rating when you scroll up and down and whatnot. Just slow down a little bit on that.
Right. Okay. Yeah. Okay. So in this one, like I said, they just gave us the costs and not the revenues. What we would do is to make the cash flow diagram for this one. So 1 million investment in the 0th period. Right. In the first period, there is another $500,000. second one, there's 800,000. And in the third one, there's 400,000. Okay. Now they told us that in the first period, there is a 50,000 unit sale. But we don't know the revenue in this case. So let's take C as the cost per unit. Okay. So the revenue in the first one would be 50K into C. Revenue in the second one would be 70K. There's 70K products sold into C. And the revenue in the third one is 100K into C. Right, that's pretty much it. So what we do for this one is, again, just find the net present worth. And the MAR is given to us as 20%. We'd also find the annual equivalent cost, but then it's not going to make a difference. Just going to stick with the present equivalent cost. Okay. So to do this, in the first 0th periods, minus 1 million. Okay. Then after that, there is 500K, 800K, 400K. All right. So what we do for this is 500. Let me do it this way. 1 million is going to be 1000K. Then 500K, so 500K. It's going to be positive, never mind. You're taking this back one period. This is in V1. So you're taking it back one period by using the MAR. 1.2. See if I can. 1.2 minus 1. This brings it in V0. Similarly, you do the same thing for the 800 and the 400. So 800 into 1.2 raised to the power minus 2, and 400 0.2 raised to the power minus 3. Take this back 3 periods and this back 2 periods. Okay. So this was all the expenses. So now for the revenue part, you're gonna subtract that because this is the present equivalent cost, right? You're gonna subtract minus C. You can just take 50K C, all right, and you're gonna take this back one period. So again, 1.2 or minus 1. Second period, there is 70K into C. The third one is 100K into C. So minus 70K C and 1.2 raised to the power minus 2. The third one is minus 100K C, 1.2 raised to the power, right? So this accounts for everything that's there in the cash flow diagram. Now we just got to solve for C in this. Let's take all these negatives to one side. So what you can do is 100K to C into 1.2 raised to the power minus 3 plus 50K into C into 1.2 raised to the power minus 1 plus 70K to C into 1.2 raised to the power minus 2 equals 1000K plus 500K into 1.2 raised to the power minus 1 plus 800K into 1.2 raised to the power minus 2 plus 400K into 1.2 raised to the power minus 3. I just rearranged this equation to help us solve it. So this first part of the equation, the left hand side, you can do for that is take C common because it's there in all the three terms. So you get C into 1000 into 1.2 raised to the power minus 3 is 50 into 1.2 raised to the power minus 1, 70 into 1.2 raised to the power minus 2. Equals, all right, I'll stop. Right, my bad.
Yeah, no worries.
Okay. So let's start solving the right hand side because there's no point of writing it down again. So 1000 plus 500. I'm just putting this in my calculator. 0.2 raised to the power minus 1 800 raised to the power 1.2 minus 2. Okay, plus 100, 1.2 raised to the minus 3. We get this as 2203.703037. All right, this is thousands. All right. Okay. So now solving the left-hand side spot, we get it as C into 100 into 1.2 raised to the power minus 3, 50 into 1.2 raised to the power minus 1, 70 into 1.2 raised to the power minus 2. Get this as 1.4, no, 148 and 148. And this is also thousands. Equals to 2203.7037. Now you just solve for C. You get 2203.7037 divided by 148, 148. You get 15.8. 15.875. This is the cost per unit. Let me check if that's right. Here's the seventh one. 14.88 is what he got. He just rounded this off. 14.88. All right, that's correct. That's how we solve for this one. Just go through this again. What they give us is the cost in the initial cost in the 0th period, and then the cost in each of the 3 periods. Then they gave us the units sold in each of the 3 periods instead of giving us the revenues. And then they asked us to find the cost per unit, or the break-even price is what they said, but that's basically the cost per unit. So does anyone have any doubts on this one? Yeah?
By the way, since you're on Discord,
For a second.
just open the Excel thing
Right, 1 second.
if you
Wait,
need
did he
it.
send it to? Okay.
It's in chat, yeah.
Right. Okay, I'll keep that open.
Yeah, just in case you need it, because I think
Yeah,
either 9 or 8, one of them.
right. So wait, I don't really know how you're
Okay,
supposed to
just
use
the
this
top.
again. So
It's not that bad. It's
yeah,
just the top is your interest rate.
right. So I just change all this, and then
And
oh, it
then
gives
it'll come
gives
up.
me all the values. Okay, right,
Yeah.
right, great. Okay, cool. So yeah. So does anyone have any doubts in this seventh one? All right, go ahead. 8th, 9th, and 10th. Okay. So question number 8. This one again, they gave us 2 different projects. Chapter 5 and 6 are basically about finding the internal rate of return, or finding the incremental rate of return. Find the incremental rate of return when there's like 2 mutually exclusive projects, and the IRR is only the IRR, not the incremental one, is for when you have only one project. And here we have 2 projects. We're probably going to need to find the incremental IRR. They ask us, no, they just ask the IRR of project A. Then what did they ask? They asked for the net present worth difference. Right, so we don't need the incremental rate of return in this. It's good. Pretty simple, okay. N equals to 0, 1, 2, 3, 4, 5, 6, 7. 7. A is negative 1500. 300, and it's just increasing every year. 100. Did I miss something up? 300, 400, 500, 600, 700. It's only till 6, right? Okay. And then project B has only till 3 periods. It's 300, 400, 0, and minus 130. Okay, so also they said that we're going to be deciding the project that would be run for an indefinite period of time. This is something we need to keep in mind. All right, I'll tell you about it in the calculations. So the first thing that we do is defining the incremental rate of return for project A. Project A, you can see that it's a simple investment because there's negative only in the first one and then all the others are positive. So we can just use the net present worth method. Present worth at the IRR is equal to 0. To do this, find the net present worth. Minus 1500. You don't need to move this front or back because it's already at V0. Then what I'm going to do is I'm going to draw the cash flow for this to help you guys understand this one. 0, 1500, and then it's like 1, 2, 3, 4, 5, 6. Okay. Then in the first one, there's 300. Okay. Then it keeps increasing by 100. It's a linear gradient. Okay. So what we can do is we can solve this like two different systems. One is this one, which is the linear gradient, and one is this, which is the equal sums interval. So this, the value of each of these is 300, and here each of these keeps rising by 100. So here it was 300. This was only 300. Then this was 400. The second one was 400. Then 500. So that's basically it. Okay. So to do this, what I'm going to do is I'm going to find the present value of this system first, of the equal sum system. To do that, 300, find given A, that there is, the rate is, what did they give the rate to be? Mar here, plus 20%. Oh, my bad. You need to find the IRR in this case. So I is now given to us. So I, and then 6 periods long. This will give you the present worth in V0. And in V0 for each of this, if you're finding the net present worth, all right? Then you have the linear gradient series that you do. It's rising by 100, 100, find P given G, so that I isn't given either, and then it's 6 periods. I'll tell you how it's 6 periods. So this is 1, this is 2, this is 3, this is 4, this is 5. So this might confuse you and you might think that this is only 5 period long because it has 5 different cash flows. But if you're doing a linear gradient, we take we take period before the starting one also. We take this period too. You get 1, 2, 3, 4, 5, 6. Right? So that's why this has 6 periods and not 5. Something we just use for the linear gradient. Okay. Now, what we do is we can find the table and substitute the formula in that. So this is minus 1500. We need to find the formula for PAIN. So it's right here.
You could use Excel for that.
No, but then
You can try.
I don't know the. Right. Okay. I'll just write down the formula.
Yeah, write down the formula.
And I will.
Save you time.
Come on. All right. Oh. So it is 300. AIN is 1 plus I raised to the power 6 because n is 6 minus 1 divided by I into 1 plus I. So what you can do in this is you can, okay, let me write down the formula for the second one too. This is the linear gradient. So you find this one. G is 100 and then 1 plus I raised to the power 6 minus I6 minus 1 divided by I square plus I raised to the power 6. All right, pretty much it. So what we do now is, let me open up Excel. Okay, so we need to find the interest rate is given, is the interest rate is not given. Oh, crap.
I think you said trial and error from 30%.
Oh man. Wait, I'm gonna have to switch. 1 second. Alright, it's gonna let me edit now. Yeah, so yeah, let's do trial and error, and they said it's from 30%. It was given in the question. We'll just pull that up again. It's right here. Yeah. So here they gave us approach started 30%. Okay. The trial and error approach. We just got a trial and error and using different I values here to get the left hand side. Oh my. Equal to 0. Okay. So the interest rate, let's start that as 30. There's 6
0.3.
periods.
0.3.
Right. My bad. 0.3.
It wasn't that advanced.
And G isn't there, right? Or
You
like
don't need
this,
G, yeah. That's just if you have a geometric gradient.
So just put this as 0. Okay. So we need PAI and here it is PAIN right here. Yeah. This is negative 1500. Negative 1500 plus 300 into 0.6427. 0.6427. Again, you use 4 decimal places for this because it's a factor value. It's 100 and BGIN is 4.6656. 0.666. Now you put this into your calculator and check what you get. Minus 1500, 300 into 0.6427 plus 100 into 0.6656. Get this as negative 240.6. Okay. So now you need to utilize this relationship that we know between I and the present value. So what we need to do in this question is we need to get something, the present value is equal to 0. Now we have the present value as negative. So that means we would need to increase the present value. And I think I said this yesterday too, the present value and I have an inversely proportional relationship. If you want to increase the present value in worth, you need to decrease the I. The present value worth should increase, you have to decrease the I. Okay, so now it was 30% and it gave us this value. It gave us a negative value, we need to increase it to a positive value, right? So let's use some other I. This was for I equals to 30%. Here, I equals to 30%. Give us this. I equals to 20%. Okay. Oh. That's right. So now we get 0 equals to negative 1500. 300 into the PAIN is 3.3255. And geometric gradient is 6.506. Plug this into the calculator. 0.3255 plus 100, 6.5806. You still get a negative value. What did I do? 1 second. We need it. What is the answer?
I don't think you get a negative value.
Yeah, I probably plugged it wrong.
Let's try again.
Okay, let me try it again. You're heading in the right direction about checking 20%. 300 to 3.2 3255. It's 100 into 6.5806.
Yeah, you get 150.
You get a positive value. Yeah, my bad. Okay. So you get this as 155.7. So now it's positive value. All right. So you know that the I is going to be in between 20 and 30%. If they give an option like this one between 20 and 30%, you would know that this is the right answer. But then they'll probably give you something like 20 to 25 and 25 to 30. In this case, you're going to need to try with 25 too. Yeah.
Could it
Now,
also
once again,
be? It could be more specific, actually, like 20 to 21, 21
I
to.
mean, yeah, they could do that too. In
Yeah.
either case, you would need to keep trying with different values. So now we're going to try with 25. So once again, here the I is positive, right? The present worth is positive. Okay, you need to make the present worth equal to 0. Now this time you're going to need to decrease the present worth. In order to decrease the present worth, you're going to need to increase the I. That's why we're trying for 25 and not 15, suppose. Anything below 20 is always going to give us a positive value. We need to get it as close to 0 as possible. Okay, so let's try with 25. Where is it? Right here. 0.25. So now we get it as 0 equals -1500, 300, and EAIN, where is it? 2.9514, 2.9514 plus 100, 0.5142. Okay, so again, let's plug this in. 0.5142. So for this one, you get -63.16. Okay, so using 25%, you're getting a negative value. Using 20%, you're getting a positive value. So that way, you know that the I is going to be in between 20 and 25. This question gave us that option. I mean, they didn't put it here, but then he just gives it to us later on in the answer key as 20 to 25%. I'll tell you how exactly to find out the exact value for I. What we do is you can make the small table, writing down the I's and the values of the present words, right? So it's going to be 3 different rows. Okay. So at I20, we get it as 155.7. I25, we get it as 63.16. Okay, negative 62.16, and you need to find it for for the value to be 0. So let's give this as x, the I that we need to find. All right, so what you do now is you subtract 25 minus x divided by 25 minus 20. Okay, and in the same order, so the third row minus the second row. So minus 63.16 minus 0 divided by minus 63.16 minus 155.7. Okay, and now we need to solve for x. X equals to, let's solve this side first. So you get minus 63.16 divided by minus 63.16 minus 155.7. You get that as 0.288, 0.2885. Okay, you multiply this to 25 minus 20. I'm taking this one. This would be minus x, and here you would add 20. Let me just 25. Okay. So the answer you multiply by 5. Okay, so you're getting 25 minus x equals to 1.442, right? So you solve for x, you get 25 minus 1.442. 3 actually, 1.443. 5 minus 1.443, and that's exactly how you get the 23 0.55. That's the exact value of I that you would need. They won't ask us the exact value, but in case they ask us its specific range, suppose they say 23 to 24 or 21 to 22, you know it's going to be in 23 to 24. That's how you get that one. Questions regarding this? It is, we just found the net present worth and then we calculated the I. All we did. We calculated that by trial and error. Okay, if there is no question, we move on to the next one. Okay. So now in this one, in the ninth question, they're asking us to find the net present worth difference. So in order to find the difference, we need to find the net present worth in each case, right? So let me just copy that table down. Where is it? It's right here. Okay. Second. Here we go. So now we need to find the net present worth for each of these cases. And for I, net present worth, this time though, they gave us the MAR and we used that. We don't use any I, we just use the MAR. So it's negative 1500. 300 find P given A, 20%, and 6 periods. Plus the linear gradient that we use, 100 find P given G, 20%, and this is also 6, right? Let me just plug this in. It is 20%. Second, 0.2. All right, so that gives us close to minus 1500. This is for A, plus 300 EAIN, right? So that would be 3.3255. So 100 GIN 6.5806. Okay, so plugging this in. Six point five eight three six. You get 155.71 as the present worth of this one. Okay. Then what you do is, all right. So one thing we need to. Okay, I'll do that after I do B. Present worth for B is at 20% minus 300. That was in V0. 500 is for 1.0.2 raised to the power minus 1 and minus 130 1.2 raised to the power minus 3 because we're taking back 3 periods. You plug this in, you get second minus 130 raised to 1.2 minus 3. Okay. Get this as 41.43. Right. So this is the present worth for each of these. In case it was having only this sort of a system where A would have 6 periods and B would have 3 periods. But then the question says that right here. The question says that the project would be run for an indefinite period of time. What we need to do for the indefinite case is that using net present worth of A, we need to find the annual equivalent cost for A. Right? So we use this formula, net present worth equals to A by I. This is only for the infinite case. Right? So if we need to find net present worth of an infinite series, we use this formula. Now we can find the AEC in this case, AEC infinite. So for A, it was 155.71 into 0. Yeah. Okay. So you get this as 311. Wait, I think.
Are you sure it's 0.2? Isn't it supposed to be A given P of whatever? Or am I?
I'm just using this. I'm just taking this up here. The I. Just rearrange this equation.
Oh, I see what you're doing. Okay. Yeah, never mind.
But I think I did mess something up. Wait, let me check where I go. This is question number 9. 7, 8, 9. Is this 9? I think this is 9. I go 155.71 and then calculated the what? Okay. Wait, what did I do?
Did what I just said. You have to use A given P and then you multiply it by the interest rate. Because that's not the indefinite present worth. That's just for one cycle.
Oh yeah. My bad.
You know what I mean?
You use that formula, but then you use it. You use it a bit later.
Yeah.
What you first do is you find the annual equivalent cost, right, for the entire period. Okay. So what you do is you find AEC A, which is gonna be find. We got 155.71, and P. You find A given P is that it is 20%, and there's 6 periods. So let's use this one. 20%, 6 periods is what? APIN 0.3007. 155.71 into 0.007. Okay. And you get this as 68.19. 0.189. Oh, 46.81. Okay. So now we can find the net present worth of the infinite series by using this formula of 46.8189 divided by I, which is 0.2. So you get 234.09. This is the net present worth to infinity of A. We do the same thing for B. We find the annual equivalent cost for B, which would be 41.43. Find A given P and percent, and B is only for 3 periods, because if you see this cycle is just 0, 1, 2, 3. It's only for 3 periods. You do this AP 20% 3. I'm gonna need to change this. So APIN, where is it here? 0.4747. 1.43, 0.4747. Okay. Right. 1.43 into 0.477. This has 19.6666867. Yeah. The annual equivalent cost. Now we need to find the net present worth to infinity for B. We need to find the difference between net present worth to infinity for A and net present worth to infinity for B. This one is going to be the A divided by I, which is 19.667 divided by 0.2, which is 98.335. Okay. Now the difference is what the question is asking us. Difference equals to 234.09 minus 98.335 which is 234.09 minus 98.25. 35.75. And is the answer. Right, let me check. Number 9, 35.75. Exact. Right? That's how we solve this one.
Can you explain like what you did?
Sorry?
Can you explain what you did in this question?
Okay. Yeah. For the 9th one, or did you get the 8th one? How I found
Yeah, I
the
got the 8th one.
IRR?
I got the 8th one.
Cool. Fine. So for this one, we just write down the tables for both of them, and then you find the net present worth for A using the MAR, which is given to us as 20%. Right? It's given right here in the question. So the MAR is given as 20%, and then you just, what you do is 1500 was already in the 0th period, right? I used this cash flow diagram that I had put here. For the cash flow, you see all this is 300. You can take it as an equal sum series, and this triangular part is a linear gradient, right?
Yeah.
You need to use the linear gradient formula for this. And in the linear gradient, the G here, 100. It's increasing by 100 every year. So just use that 100 PG 20% 6, 300 PA. I just put in the formula. I got 55.71 as the net present worth. Okay. For B, what I did is I just simply took all of them back to the V0. This 300 is already in V0. I took 500 back one period, 1.2 because minus 20% again, minus 1. And then I took the 130 back 3 periods because it's in the 3rd period. I took that back to V0. All right. Get this as net present worth of B as 41.43. Now you need to calculate the annual worth of NB, the given periods. So I need to calculate the annual worth of A for 6 periods and annual worth of B for 3 periods. That's what I did here. A given P 20% 6, and you get that as 46.8189. And similarly, find A given B percent 3 this time because B is for 3 periods. So you get 19.667. After that, I mean, I did this before, but then what the question's asking us is it's an indefinite period of time, and we need to find the net present worth difference, right?
Yeah.
So we need to find the net present worth of A even if the project was infinitely long. So the formula to do that is what he gave us in, I think, in this chapter itself. Net present worth at infinity equals A by I, right?
Yep.
So that's what I just did here. A is, we just calculated A, and I is the MAR, that is 0.2. You get this value. Okay. Do the same thing for B. A by I, 28.335 is what you get. Asking you the difference between the two projects. So you just subtract them, and you get 135.75.
I get it. Thank you.
All right. Cool. Fine. I think this will be the last question for this chapter, and then we'll do chapter 11. Number 10. All right. What is this asking us? No. Okay. The incremental IRR. Okay, this is simple. So what we need to do for this one is, okay, let me just write these tables down. Why is it so dark? Okay, never mind. A, and for B, 0, 1, 2, 3, 4, minus 900, minus 600, minus 590, 0, and minus 400. Again, minus 900, minus 900, minus 100, 0, and minus 521. So they're asking us to find the incremental IRR. Like I said, for the incremental IRR, you either need to do B minus A or A minus B. So now let's do both of these to find out which one will we need. So if you do B minus A, you get 0, minus 300, I think it is minus 490. No, it's 490. 0 and minus 521 plus 400 is minus 121. Okay. If you do A minus B, you get 0 in the first one, then you get 300 minus 490, 0 and 121. Another thing about incremental IRR is that you need to make sure that your first non-zero value is going to be a negative. In this case, both the first periods are 0, so it doesn't matter. In the second period, the first one is negative 300 here and 300 here. So because of that, we cannot choose A minus B. We've got to choose B minus A because the first one needs to be negative. Okay. So we took the B minus A. Now we need to find the IRR for B minus A. IRR for B minus A. To do that, okay, again, now the next thing here is we need to check if this is a simple or non-simple cash flow. You got the negative here, you got a positive, and then you got a negative again. It means it's a non-simple cash flow. There's sign changes that happen here. What you need to do for that is you need to follow the project balance method. So the project balance at the fourth period, at the end of the fourth period, is going to be 0. So now what you do is to do this, you start by finding the project balance for every single period. Project balance at 0. Let me draw the cash flow for this at 0, 1, 2, 3, and 4. The 0th period, there is no payment right here. It's 0. At the first one, there's minus 300. And this goes like this. There's a 490 payment. Okay. And it gets affected by MAR right here. It will be at this point. Then again, it gets affected by MAR twice. It would be at this point, and then there's a negative 121 to bring it back to 0. This is the 121. Right? So this is how the cash flow would look like. Here, wait, we'll just. Can you guys still hear me? Okay. So here the IR would be the thing affecting, and here it would be the MAR. Here and here. Okay. Now that we have the cash flow, we know what we need. So PB0 is going to be 0. Project balance at the end of the first period is just 300, negative 300. Okay. Then in the second period, the IRR is going to be affecting the project balance in the first period. So minus 300, going to be moving it forward by the I, 1 plus I, 1 period forward. And we also have a $490 payment, plus 490, because this is being added. Positive here. This is the project balance at the end of 2. Now project balance at the end of 3. Here's no payment here. It's 0, but then we still need to, use the MAR to carry it forward to the third period. So minus 300, 1 plus I dash, plus 490. And using the MAR was 10%. So 1.1 raised to the power 1. So this way, this goes to the third period. This whole thing is in V3 now. All right. And then in V3, there's no payment, so you don't plus or minus anything.
You mean 1 minus
in
0.1?
In the fourth period, project balance 4. What you need to do for this is you need to apply the MAR again to the project balance 3. So it would be PB3 into 1 plus I raised to the 1 plus the MAR, that is 1.1, and minus 121. We know the PB3 is this spot, so minus 300, 1 plus I is 490. This is not 1 minus 1, it's 1.1. 1.1. And it's being multiplied by 1.1 again, so 1.1 squared minus 121. This is the final thing. You get this and you're almost done. What we need to do is, we said that PB4, we need to equate that to 0. equated to 0 and solve for I. So I'm going to rearrange this so that only 1 plus I is left on the side. Basically, you take the minus 121 to the other side, so it's going to be 121. Divide that by this 1.1 square. Then take this 490 to the other side, minus 490. Divide that by this minus 300. Okay, you've taken everything else. Now let's take this 1 also. All you're left is with the I. It was plus 1 here, so it's going to be minus 1. And this way you just plug in everything into your calculator. 121 divided by 1.1 square minus 490 divided by minus 300 minus 1. You get this as 0.3, which means the IRR is 30%. That's pretty much it. Yep, 30%. That's all you do for this one. Do you guys have any doubts on this one? No? All right then. I think we'll go forward to the next one. Now we'll be doing the chapter 11. It has only one question, but with 10 subparts. Okay. Chapter 11. Fine. So the way I'm going to start is I'll start by, all right, so in this one, there's the defender and the challenger. We need to find a lot of stuff regarding the defender and the challenger. What I'll start by doing is I'll draw the cash flow diagrams for both of them. Okay. So in this one, it's a 5-year-old tooling kit. It was purchased for $12,000. That doesn't affect us now, okay? And it has a current market value of 5,000. This is what we'll be using. 12,000 is absolutely waste. And expected operational costs are 2,000 per year, and then 2,000 in the first year, and then it's increasing by 1,000 every year. Right. Need an immediate overhaul of the kit. This we'll need. Okay.
So hey,
500.
your screen's a bit like pixely, so just okay. No, it's good. You might want to zoom in on the PDF a bit.
Right. Second. Now?
Yeah, now it's more clear. Alright, it's good.
I'll try to do a bit more.
Yeah, do a little bit more. Alright, perfect.
Is that good?
Yeah, it's good.
I think we can go a bit more. Let's see.
Just because when it's small, I guess your
Yeah.
screen doesn't pick it up.
This is good too. Is this fine now?
Yeah, that's fine now. You're good now.
Okay, cool. Yeah, like I said, the 12,000 has absolutely no use to us now. The operational costs are 2,000 in the first year, and they increase by 1,000 every year. Okay, and you need an overhaul right now of $500. So we're going to use that too. Future market values are expected to decline 25% annually. So what they're saying is the salvage value is going to be decreasing by 25% of this initial market value. It's going to decrease by 25% annually. Okay. So, and the max we can use this kit is for another 5 years. That's it. All right. So you need to find the optimal plan for this kit. Let's draw the cash flow diagram for this one. So now the current market trade value is 5,000. So that's what you use as the opportunity cost. And then there is a $500 overhaul right now. So you get 5.5K. All right. Then, oh, come on. Okay. Then what else is there? It's the operational costs are 2,000 in the first year. 0, 1, 2, 3, 4, and 5. In the first year, it's 2,000. Okay. And then in the second year, 1 second. Let me try to change this. Okay. That should fix it. Hopefully. All right, it's 2K, and then it increases every year by 1,000. So it's gonna be a linear gradient here. Okay, something like this, increasing by $1,000 every year. What? Okay. Oh man. Okay, my bad. Sorry, guys. All right. Yeah, where was I? All right. So the salvage value now. They said that the salvage value is decreasing by 25%. So in the first year, it's going to be 75% is what is going to be remaining, right? 75% of 5,000. So you do 5,000 and 0.75. Let me check what this is. Wait, will we need it every year? Okay, yeah. Let me just put that as 5K into 0.75. Okay. The second year, if you would be selling it off in the second year, your salvage value would be 5K into 0.75 square, because it's decreasing by 0.25 every single year. In the third one, it would be the 5K into 0.75 cube, and so on. All right, it would be something like this. Again, a geometric gradient in the opposite direction, but that doesn't matter. All right, this is the cash flow diagram for the defender. Let me do the same thing for the challenger now. The challenger's current purchase price is 11,000. Its market value is 40% lower after 1 year, and then it just keeps decreasing linearly by $2,000 each year. The operational costs are 1,000 in year 1 and increasing at 30%.
Wait, so hey,
And the maximum.
Where'd you get 5.5 from?
So yeah, the opportunity cost right here is 5,000, and you need a $500 overhaul, right? It's
Isn't that
5.5K.
12,000 plus 500?
No. 12,000 was when it was purchased 5 years or something. I don't know, a few years ago. It has the current market value of 5,000, and that's what we use.
Oh,
2,000, we don't use that.
Okay. So the 11,000.
Give me 1 second. Yeah, give me 1 second. Let me just charge this.
Yeah, no problem.
What up, boys?
Hello.
You sound like you got a lot of sleep.
Yeah, totally. Definitely not 5 hours.
Sleep
Definitely.
gang.
Right, I'm back. Yeah. Okay, so let's start with the challenger's cash flow diagram now. Challenger's current purchase price is 11K, and after 1 year, the market value is less by 40%. So let's just calculate this. It's going to be less by 40%, so it's going to have 60% of its value left. You get this as 6,600. Okay, 6,600 is going to be the market value, the salvage value after 1 year. 0, 1, 2, 3, and 4. You know that the market value decreases 2,000 every year. So it's going to be something like this: 4,400, 4,600, 2,600, and 600. That's going to be the salvage value in each year, depending on which year you're going to sell it. Okay, the operating costs are $1,000 in year 1, 1K, and it increases geometrically, okay, like this. And the gradient is 30%. Okay, but I'm just going to calculate this now itself, because it's going to be easier this way. So 1K in period 2, 1K and 1 point increasing by 30%, 1.3 is going to give you 1.3. In period 3, the operating cost is going to be 1.3 increasing by a 30%, which is going to give you 1.69. In period 4, 1.3, 1.69 into 1.3 is going to give you 0.197. These are thousands, so 1.3K, 1.69K, and finally 2.197K. These are the operating costs. That's all you need for the 2 cash flow diagrams. All right, now we go to start the solving part. First question asks us to find the N star D and AEC star D. That is the estimated service life, the most efficient estimated service life for the defender, and the cost during that service life. All right. So to do that, let me put this up here. Okay. All right. So to do that, we find out the cost in each year. A1, this is for the defender now. So what you do is you're going to be taking this 5.5 forward to the first year, so 5.5, and you're taking it forward. And what is the MAR? All right, the MAR is 15%. They didn't specify this anywhere, but then they gave it here. Unique minimum ECN, 15% for both the kits. So that's the MAR, all right? So 1.15, taking it forward by 1.15. And in the first period, we have 2K of operating charges minus 5K into 0.75 of the salvage value. You calculate this, it's going to be 5 into 1.15 plus 2 minus 5 into 0.75. You get it as 4,000? No, wait, my bad. 5.5 into 1.15 plus 2 minus 5 into 0.75. 4575. That is the cost for keeping the defender for 1 year, all right, for the first year. Now we need to find it for A2. A2, you're going to take this 5.5K and you're going to annualize it over the next 2 periods. Similarly, what we're going to first do is we're going to take all this 2K and this is increasing by 1,000, right? So this is 3K, this is 4K, 5K, 6K. Those are the operating charges. We're going to take 2K and 3K back to the V0 first. I'll show you guys.
Wait,
0.5K.
for A1, do you not have to put it back, or?
So the thing is, when you're going to annualize it, right, it's going to start from the first period. And so, like, this 2K and 5K into this is already in V1, right? So all you need to do is you need to take this to V1.
Oh, I see. I didn't see that. Oh, yeah. Okay.
You need to make everything in V1. Now, in this case, though, you're annualizing it over V1 and V2. Okay. All right, someone's unmuted. Okay, I guess I'll just ignore. Yeah, okay, never mind. All right.
I think it's good now.
Yeah. Right, so this 5.5K, what I'm going to do is I'm going to take this 2K operating charge from V1 and put it back in V0. 2 divided by 1.15. All right. You know, if this doesn't make sense to anyone, this is the easiest method I found. Then the next one is 3, and I'm going to take this back 1.15 again, right? So 3 to V0 again. 3 divided by 1.15 square, because I'm taking it back 2 periods. And this is V0. Okay. Now I need to annualize this. To annualize this, I need to find A given P, 15%, and over 2 periods. Okay. All right.
That's just
so
the cost, isn't it? Because you also need the.
yeah, my bad. The salvage value. Yeah. So the salvage value is 5K into 0.75 square, and then you need to annualize this over the 2 periods. So it's going to be find A given F, because the salvage value is in V2, 15% and 2. I'm going to change this very light. Okay. So now you calculate this. All right. So to be honest, I guess I'm just gonna show you guys what I did, because there's like half an hour left and this is gonna take a lot of time if I write everything. No, this is chapter 14, chapter 11, right here. This is the quiz. This is the quiz, right? Yeah. This is what I did for A1. You do this, you get 4575 for A1. That's what we got just now. Similarly, you do what I just wrote, 0.5 plus 2 divided by 1.15 plus 3 divided by 1.15 square. Then you annualize that, you take the salvage value, annualize that, you get 4540, right? Then you do the same thing for A3. A3, if you see, has a 5.5K, and this one that we're talking about. A3 is going to be this, okay? So the 5.5K, it has the 2K operating charges here, 3K here, and 4K here. You take all of those back to V0. This you divide by 1.15, divide by 1.15 square, 0.15 cube, all back to V0. And then you annualize it over 3 periods. Okay? Similarly, you do the same thing for the salvage value. The salvage value in the third period is 5K into 0.75 cube, and you annualize that, right? So you use this factor values and you calculate it. This is what you get, okay? So now the thing is, A1 was 4575, A2 was 4540, and A3 is 4708. So you can find that A2 is lesser than A1 and lesser than A3. So A2 is the minimum, right? That's what you need to do for these questions. You need to find the minimum, all the A's. So if let's say A3 would be lesser than A2, what we would do is we would find A4 after that, do the same calculation, find A4. We would see that whether A4 is less than A3 or whether A3 is less than A4. In this case, A2 was less than A3, right? A2 was 4540, and which is less than 4708, which was A3. So due to this, we know the most efficient cost plan is keeping the challenger for keeping the defender for 2 years. N star D equals to 2, and AEC, that is the most efficient cost for D, is going to be 4540. Right? This was for the defender. We do the same thing with the challenger next. All right. So for the challenger, A1 is going to be 11, because this was the cash flow diagram for the challenger. So what you're doing here is you're taking the 11K 1 period ahead, and you're adding the 1K of the operating charges, subtracting the 6,600 of salvage value. You get 7050 in the first period. All right. Stop me if you guys have like any doubts, because I know I guess I'm going a bit too fast, but then like we barely got time to do all this. So stop me if you guys have any doubts. Okay. So for A2, we need this, right? You got the 11K, and like I said, I'm taking the operating charges 1, dividing it by 1.15 to get it back in V0, dividing this 1.3 by 1.15 square to get it back in V0, because this 1.3 is V2 and this 1 is V1. We need to take all these back to V0, right? So that's what I'm doing here, and then I'm annualizing it over the 2 periods. Now at the end of the second period, look at this, you can see that the salvage value, which decreased from 6,600, it became 4,600 now. So that I wrote that as 4.6 because I'm taking it in K, or like just writing 4.6K. I'll show you guys. 4.6K is what I'm doing. All right. So, and then I'm annualizing this salvage value over 2 periods, and you get 5766.1. Okay. Next, you do the same thing for A3. So now we got done with A1, A2. The challenger is available for 4 years, so we're going to need to find every A till we find something that's lesser than the previous, that's greater than the previous one. Okay. So now A2 was less than A1, but we need to find something that's greater. Okay. Let's go with A3. A3 is this. Okay. So for A3, we have the 11K. We have the 1K from period 1, which we take it back 1 period. 1.3 from V2, which we take it back 2 periods. 1.69 from V3, which we take it back 3 periods. That's the end of all the costs. You annualize the costs after that. find A given P such that it's 15% and 3 years. So you annualize that. And then what you do is this salvage value drops to 2.6. From 4.6, it keeps decreasing every year by $2,000. So it drops to 2.6 and you annualize it. So you calculate this and you get 5367.3. You realize that A3 is still greater than A2. A2 was 5766, A3 is 5367. It's still greater. So you need to find A4 now. Right? To find A4, you take the whole thing, the entire Challenger series. Okay. 7 plus 1K for the operating charges, 1.3K, 1.69, and 2.197. All these are the operating costs. Divide that by 1.15, 1.15 square cube, and raised to the power 4. Get it back in V0. Annualize it. Same thing that we did in all the others. Annualize it again. And then here I'm removing the salvage value. That is, it's 0.6 because it dropped to 600 now. From 2600, it's dropped to 600. So you annual.
Mute.
You're unmuted. What that is.
Feels bad. Okay, continue.
Right. So yeah. Salvage value, I'm annualizing it over the 4 years because this is the entire series. And you get that as 5211. All right. You know that this 5211 is less than all the other A's, right? This one was 7050, second one is 5766.1, third one was 5367.3, and the 4A4 is 5211. This is the most efficient cost for the Challenger. You write that as AEC star is 5211. Similarly, the estimated service life, the most efficient service life for the Challenger is 4 years. This is the answer for like the first two parts. The first one asks the estimated most efficient service life for the Defender and the cost, and then the next one asks that for the Challenger and the cost. Right. Now for the next questions. So for this question, what he's asking us is he's given us this plan J0 D star and J3. What this means is J0 means the Defender. D star means how many years the Defender is going to be used. D star, we know it stands for 2. Then J means the Challenger. This is the Defender. The Challenger. Again, J is the Challenger. This means is we're going to use the Defender, its service life, the 2 years. Then we're going to use the Challenger for 3 years. Then again use this. Then like after these 3 years, we're going to sell the Challenger, and again buy the Challenger again and use it for 3 years. This is what our project is going to look like. All right. So they want us to find the present cost of this project. The cash flow for this, let me show you guys. The cash flow for this would look something like this. All right. So you've got the 5.5K from the Defender, the 2K of the Defender's salvage, the operating cost, the 2K of the Defender's operating cost, then the 3K of the Defender's operating cost, and then the 5K into 0.75 square of the Defender's salvage value. This is one. This is the first plan, the J0 ND star. Right here, J0 ND star. That was the first plan. Then we have the J3 and J3. I'll just do it that way. Okay. I guess it's a bit blurry now, right? Is it fine now?
Yeah, it's good.
Okay, cool. So this is the first plan. This is the second, and this is the third. This I didn't write it again for the Challenger. I'll explain it now. So for the Challenger, it's 11K cost in the first year, this one, right? And then it's 1K operating charge and 1.3K operating charge in the next period. Then the salvage value at the end of the 3 periods is 4.6K. We're gonna follow this again in the second cycle. The same thing again. I didn't draw it, but that's gonna be the same thing. Now we need to find this is the entire plan. We need to find the present equivalent cost for this plan. So that's what I'm doing here. Right? So what you do is you take 4540, and the way I got 4540 is because if you see AEC of the defender, the annual cost for the defender, that is 4,540. The defender is going to be used for 2 years, right? ND star. So this is the annual cost. I said find P given A, and this would give me the value in V0. Okay. I do that for the challenger. So what I do for the challenger is the annual cost for the challenger after 3 years. If you guys remember, right here, when we did the A3 calculation for the challenger, this one, you got that as 5,376.3. 5,376.3. So that's what you're using here, right? 5367. Okay, and this would be the annual cost for the challenger, right? First thing I'm gonna do is we have 2 cycles of the challenger. So for that, first thing I'm gonna do is I'm gonna find the present cost of these 2 cycles. Okay, the present cost of these 2 cycles. Notice that I did 6 here instead of 3, because normally it would be 3, but then the challenger is being used for 3 years and then again 3 years, so I did 6 directly. So this would give me the present cost in V2, right? Because the present cost would be like 1 year before the cycles, so it would give me in V2. Yeah, it's going to be in V2. Okay. Then after that, but I need the thing in V0. This PEC is in V0. I need everything in V0. I need to do this V2 converted to V0. That I use the find present worth such that the F is given. This makes sense. This is what I'm doing right here. So find P given F, 15.2, because this part in V2. So to drag it back 2 periods backwards, I'm using this one. Okay. Does this make sense?
Hold on, I have a question. So it's like, what I don't get is, like, we have this happening twice, right? But doesn't this only account for the one at the very last 3 years?
No, it doesn't. So the thing is, if I would write these annual costs in a different cycle for the challenger, it would look something like this, right? 3 years for the challenger, first cycle, then again 3 years, correct? In the second cycle. What I did here is I used 6 instead of 3. I counted for all the 6 cycles right here.
Oh, I see. Okay.
So I counted for all these 6 cycles, and I found the present worth of these. So it would be in the previous period, and then I dragged it back 2 more periods.
Got
What I
it.
did. Okay, no problem. Any other questions? Because like if you guys get this, then it will be pretty simple to understand all the other stuff. I know this might be really confusing at this point. Then yeah, this is how you do it. So let me know if you have any questions right now. Okay, fine. So yeah, what I'm doing is V2. This would be this annual cost would be in V2. When you bring it to the present worth, it's going to be in V2. So you drag it back 2 more periods, you get it in V0. I calculated all this, like you just substitute for the factor values and you calculate that, you get it as 22,738. This is again K. So that would mean $22,738.128 is the present worth. Let me check if this is right again. It is right. I already did this. Yeah, 22,738.13. We're close. I guess that doesn't matter because it's probably the rounding. Okay. So this is how you do for the present worth of the given plan. Now what it's saying is find the AEC of the given plan. So this is just really simple. What you do is you just annualize the present worth that you got here. To do that, just like take this present worth. Let me write that again. 7.3. Take this present worth and annualize it. Okay, again, I'm doing this for 8 periods now. Wait, let me this. I'm doing it for 8. Oh, I'm doing it for 8 periods because the whole plan, this was for 2 periods, this first thing. This was for 2 periods, this for 3 periods, and this for 3 periods. So in total, it was for 2 plus 3 plus 3, that is 8 periods. So I'm going to annualize it over the entire plan. That's what we need to do. So that's what the reason I wrote 8 here. And you just substitute that factor value. You get this as your answer for the annual equivalent cost of this plan, the plan they gave it to us, right? Okay. Now, this question is the same thing that they asked us in the quiz. I don't know which quiz that was. I think that was the second last quiz, but find the most cost-efficient indefinite plan. When they say indefinite plan, what they mean is that, let me write it here. I did write this right here. I'll erase it and I'm going to write it again. What they mean is that you use the defender for a specific period of time, J0. I'm going to take it as n. And then you use the challenger for different cycles. And you always use the challenger for its estimated service life, the most cost efficient life, all right? And then you keep using it like this infinitely, all right? This thing gets repeated again and again and again because they said indefinite plan. So it gets repeated over and over again. So the main thing here is the challenger is always used in its most cost efficient time, the estimated life, while the defender may or may not be used in its cost efficient life. So for the defender, the cost efficient life was 2 years, if you guys remember. And for the challenger, it was 4 years right here. The AEC for the challenger was 5211, I guess. Yeah, 5211.1 right here. And the AEC for the defender was 4540 right here. Okay. So this is what the indefinite plan would look like. All right. Use the defender for a specific period of time, use the challenger for its estimated service life, and then keep repeating the challenger infinitely. All right. So now we need to find whether it is this part. I'll do it later. I'll do it right here. Okay. So this is the plan. J0 stands for the defender. This might or might not be n star. Then J stands for the challenger, J0 for the defender. This is going to be n star C. And then again, J n star C and infinitely, right? What we need to do is we need to find how many years are we going to use this defender. Okay. To do that, we need to perform marginal cost analysis. What that means is that we need to find how much extra would it charge us to keep the defender 1 year more than the estimated service life, right? The estimated service life for the defender was 2 years. We need to find how much would it cost to keep it for the 3rd year or the 4th year, all right? So 1 second. Okay. Yeah, this is what I did here. You need to perform this marginal cost analysis. All right. Wait, was there any other question? 6. We did 6, right?
Yeah.
Wait, we
isn't-
skipped 2 questions?
You skipped it, yeah.
Did we? Yeah, I think we skipped 2 questions. My bad. 10 6, right. Okay, so it's basically the same thing that we did in third and fourth question, but then I'll just go over it again quickly. So what it's saying in the fifth question right here is what is the present equivalent cost of this plan that they gave us? So the Defender is being used for its service life, right? The Challenger is also being used for its service life, and then the Challenger keeps getting renewed infinitely. Right? So to do this, use this formula that we used in the previous chapter again. Worth of an infinite series is equals to divided by I, right? So you know that the Challenger is being used infinitely, right? Okay. So the AEC of the Challenger, the most cost efficient plan, it was 5211, okay? And the I is 0.15 because that's the MAR that they gave us. So 5211 divided by 0.15, and you get this as 34,740. But this is in V2 because this was wrong. This was not for this question. For question number 5, they gave us J0 ND star and J NC star to infinity, right? So this is being used for 2 years, and this is being used infinitely. So when you find this out, it's going to be in V2, right? But we need to find it in V0. That's for the present worth. We always find it in V0. So to drag it back 2 periods, we're going to use this 1.15 raised to the power minus 2. You drag it back 2 periods, you get this. This is the present worth of the Challenger in this plan. So this part, we're done for. Now we need to find the present worth of the Defender. Okay? So to do that, what I did is, okay, we had already done this previously, right here. If you guys remember this one. Yeah? 4540 was the estimated cost, annual cost for the Defender, the most cost efficient plan.
That's the present worth, right?
I hear you.
Can you hear me?
Yeah, I hear you now. Yeah.
Okay, that was just the present equivalent cost for the Defender. That portion, right?
This one? Oh, this one. You mean this one, right?
Yeah, I think so. I don't know if you're drawing or not, but the 4, 5, 4. Yeah, that one.
This, right?
Yeah.
Yeah, that's the present equivalent cost of the Defender itself.
Ah, okay.
This part is for the Challenger. This is for the Defender. This was the present equivalent cost of the Defender. That's what I didn't do that again. I just copied the value from here. Okay, so 7.380, that's $7,380. That's what I wrote here. Present cost of the Defender while using the estimated service life. You have this and you have this. You just add them and you get 33,649 as your present equivalent cost of this plan that they gave in question number 5. All right. Now, in question number 6, it's asking us the annual equivalent cost of that price. So again, it's now the thing that we use here in question number 4 for finding the annual equivalent cost. What we did was we used this factor value formula, right? And we did it for 8 periods. But we know this plan in question number 5 is an infinite plan. Here, it's an infinite plan. Okay. So since it's an infinite plan, we're going to be needing to use that formula that gives us present worth of an infinite plan is equals to AEC divided by I. You take I up there, it becomes I into present worth, gives you the AEC. That's what we did here for question number 6. So that's what I'm doing here. Present equivalent cost into I, and the present equivalent cost was 33,000. 33,649.1 into I, which was 0.15. You do this, you're going to get the annual cost to be 5,473. That's pretty much it for question number 5 and 6. Getting back to question number 7. That was the one with the infinite plan. So now we need to find what would be the cost for using the challenger, for using the defender in the third year. Because we know that using the defender for 2 years is the best plan for using the defender alone. But we need to find the best plan for using the defender and the challenger together. So for that, we find out what is the best plan for using, what is the cost of using the defender in the third year. That is called the marginal cost. In the third year, it's going to be, the cash flow diagram is going to look something like this. This is the diagram for the defender, all right? I'll draw this part again. So this is the V2, okay? For marginal cost, the thing we do is we only calculate it for 1 year, from the second to the third period. Second to third. Second to third period, right? So this would give us the MC3, marginal cost in the third period, okay? So in the second period, if I go back to the original cash flow diagram, right here, for the defender, you can see that in this second period, we're finding this out. Oh, crap. 1 second. It was something like this. Okay. So right now, we are using this, only the second to third period. So in the second, that the opportunity cost right here is 2K. And in the third period, the operating charges are 3K. As in the end of the second period, salvage value, you can calculate that. That's what I'm doing here. Right, so in the second period, the opportunity cost is going to be 5 into 0.75 squared. That was the salvage value of the second period itself. Okay. Let me erase and write this again. So this is 5 into 0.75 square, and this is going to be 5 into 0.75 cube, right? Because that was how the salvage value for our defender was changing every year. It was being decreased by 25%. And then the operating charges in the third period are 45K. I mean 4K, my bad. Okay, so we just do the cost analysis for this one period. Okay, so to do that, what I'm doing is the 5 into 0.75 square, this, I'm taking it forward one period. That will make it in V3. Right? And these two are already in V3, 4K and the 5 into 0.75 cube, that's already in V3. So all you do, you just calculate this and you're going to get it as 5.25K. Right? Now, the method that you use for this is you compare this 5.125K with the AEC of the challenger. AEC of the challenger was 5211, right? You realize that the marginal cost of the defender in the third year is 5125, which means it's cheaper to use the defender in the third year than it is to buy the challenger in the third year itself. So like, instead of selling the defender and buying the challenger in the third year, it's cheaper to keep the defender for the third year. So that's what we're going to do. We're going to keep the defender for the third year. All right. Similarly, we do the same marginal analysis for the fourth period. This time we take the third to fourth period. This is period 3, 4. We take this. So the opportunity cost would be the salvage value, the original salvage value in the third period. That was 5 into 0.75 cube right here. If you see this, this was the salvage value in the third period. That would now become our opportunity cost. Okay. Next is the 5K, which is the operating charges in the fourth period, and the salvage value in the fourth period, that is 5 into 0.75 raised to the power 4, because again, it decreased by 25%. You calculate this using the same formula. I'll write down here, 1 second. So you use pi into 0.75 cube, and you take it forward by 1.15, all right, to bring it to V4, okay? And then minus or plus 5K, that is the operating charges right here, and minus 5 into 0.75 raised to the power 4. All right. This is this plan. Okay, no, this isn't. But yeah, this is, you solve this and you get, wait, let me do it real quick. 5 into 0.75 cube into 1.15 plus 5K minus 5 into 0.75 raised to the power 4. You get this as 5843.75. Now again, you compare it with the AC of the Challenger. This time, it's greater than the AC of the Challenger, which was 5211, right? It's greater than the AC of the Challenger, so that means it costs us more to keep the Defender in the fourth period, because this is MC4, than to use the Challenger in the fourth period. So we just we use the Defender for 3 periods and then sell it off, because in the fourth period it's costing us a lot. So you sell it off at the end of the third period and you buy the Challenger instead. So the most cost efficient plan that they're asking us is going to be this. I'll just show how I got that again. So since MC3, since we'll be using the Defender for 3 years, we write that as J0, 3, and we'll be using the Challenger for its estimated service life. You never change this thing about the Challenger, right? It's always the N star C. The N star C in our problem is right here, 4 years. Okay. So it's always going to be 4 years. And we know it's an indefinite plan. So infinite. This is our most cost efficient indefinite plan. Okay. We're almost done. All right. So now they're telling us to find the present equivalent cost of this plan, right? It's similar to what we've done in all these third, fourth, fifth, and sixth questions. I'll just do it real quick. Okay, so we know that to keep the Defender for 3 years, if you guys remember question number, which one was it? Did we keep the Defender? No, we never kept it for 3 years. Okay. So what I did instead was I took the cost of keeping the Defender for 2 years, and then I added MC3 to that. Okay, because the cost of keeping the Defender for the third year is MC3, right? This one, 5.125K. This is the cost of keeping the Defender for the third year, and the cost of keeping the Defender for the first 2 years is what we did up here. Right here, present worth of the Defender is this. Yeah. And here, again, I copied it from here. This one. Oh my God, I'm drawing so much. Okay. This, the present worth of the Defender after 2 years, that's what we're using again here. So this was our plan. So to do that, we're just adding the present worth of the Defender after 2 years. And then we need the present worth of the Challenger, of the Defender in the third year also. So The cost of keeping the defender for the third year is MC3 equals to 5125, right? This, though, is in V3. We need to drag it back to V0. So the present worth of this MC3 is going to be 5125 and drag it back. So find P given F, 15%, and 3 periods back. So that's what I did here, if you see this. Okay, so that would conclude it for the defender part of the plan. Now we need the challenger. For the challenger, again, we use the same method that we used here in this question. You see the challenger was following an indefinite plan. So we use this method here. I'll zoom in. We use this, if you guys remember. We use this to calculate the AEC and then the present equivalent cost for the challenger. The AEC for the challenger, AEC star for the challenger is 5211. We use the formula, we divided PEC of the challenger for an indefinite series is going to be AEC star divided by I. So you divide that and you get the answer here. You get it 34,740, okay? 1 second. 34,740. But this is in V2, right? Or which V is it in? Let me check. Because in this plan, okay. So now since, yeah, right here. This, it was in V3, okay? Because we're using the defender for 3 years, right? So when you find the present worth of the challenger, that's going to end up in V3. So you drag it back by 3 periods. Here, this is V3. So you drag it back by 3 periods. So what do you do? Find P given F, 15%, 3 years. You calculate this. That's what I did right here. Here. Oh. Here. Okay. 5.21 divided by 0.15 and taking it back 3 periods. So, and then adding it to the, adding it to the present worth of the defender, you get this as the present worth of your entire cycle. Right? The present worth of your infinite cycle. This plan, the present worth of the plan is this. 33,593 is, yeah, 33,593 is the present worth of the indefinite plan. So we're done with part 8. In the 9th, they just ask what is the annual cost of your optimal plan that you found here. The annual cost is going to be, for this, again, we use that same formula for the indefinite plan. The PEC equals to the AEC divided by I. So you take I up there and you get it as I into PEC equals to AEC. Do that same thing to find out AEC, right? Just take the PEC that you got here, multiply by 0.15, you get 50,389 your annual equivalent cost of your most optimal plan. Now the final question asks us, what is the error of keeping the defender 1 year longer than is cost efficient? So we found out that keeping the defender 3 years was the most cost efficient thing, right? They're asking, what is the error? How much money would we lose if we would keep the defender for 4 years instead of 3 years? And we found out that the cost of keeping the defender for the 4th year alone, the MC4, we found that here. We found that it is going to be 5843.75. I just don't know why I left the 0.75, but 5843. Then the cost for keeping the MC3, no, which one was it? Yeah, the AEC star. Why am I subtracting? My bad. So MC4 is 5843. So the cost of keeping the defender and challenger together for 1 year extra would be 5843 minus 5211. That is 632. All right, but that would be the cost in V3 or 4 V4. Yeah, this would be in V4 because we start using the challenger from the fourth period right here. So this would be in V4, but it's asking us in the question to find it in present value. So you divide that by 1.14 here, and you get the present worth of that error as $361. That's pretty much it. So you guys can ask me any questions you have. I know this is extremely confusing if you're listening to it for the first time, but if you go through these again, I'm pretty sure you'll get it. So yeah, you can ask any questions you guys have.
Can you just like check the answers?
Yeah, 1 second.
So P was
Alright.
what?
The 8th one,
Yeah, what was that in your part? Was that? Oh, I see it. Never mind.
it was the same thing, yeah.
And then
Here.
A was that calculation. Okay.
Yeah, I got it off by $1, but I think that's fine.
Yeah. And then yeah, you got 10. Okay.
Then
Bro, if we gotta pull this off during the midterm, I hope it's not this long.
no, it won't be this long. See, what he did for us is just give one question for the entire chapter. It covers the whole chapter 11. So if you want to practice chapter 11, you just make sure you can do this one question, and you'll be able to pull off anything he asks you for chapter 11.
Yeah.
Yeah.
That's true. And also, I guess he'll like ask like maybe 3 or 4 questions from 11. So
He'd
Yeah.
ask 3 or 4, but then it'll be like 3 or 4 from these. So he would just tell us this one, and then find the most cost efficient plan. This cost efficient indefinite plan is what they asked us in the quiz too. Remember, wait, I have the
I
quiz
don't
right
think
here.
he's gonna do the marginal analysis together, because I think I asked him and he said that he won't be combining it like that. Like if he's gonna do it, he's gonna do it separately, or like he'll give you
Yeah, he said
the other part of the marginal analysis and then tell you to do it.
something like this one, something like the second quiz question.
Yeah, like that.
So he gave us all this. He told us to find the optimal plan.
I see. You guys also have chapter 5, right?
Yeah, we did
have
that-
Chapter 5 and 6.
Did that? Yeah.
I don't know. I'm kind of nervous because we did chapter 5 on the midterm, but so we have like less to do now. But that just means these questions could be like more difficult.
No, I'd just tell you to practice chapter 5 too if you got time, because like most of the stuff in chapter 6 is almost like a 90% related to chapter 5. Chapter
Yeah,
6
yeah.
only
already
talks
got-
about the. Sorry, go ahead.
We already got tested on 5, like on our shell. It's just 6, 8, 11, 14. There's no 5.
Yeah. But then the thing is, see, chapter 6 only asks about the incremental IRR, right? And you don't learn how to do the IRR anywhere other than the chapter 5. So you need to make sure you know how to do the IRR.
Yeah, it's just that one formula basically.
Yeah.
Yeah. What was 6th again? It was the it was just like me doing annual equivalent worth and stuff and comparing and again, right? Isn't anything special?
Number 6.
Yeah, what was
Are you-
6 again? I
Chapter
just
6,
forgot.
chapter 6.
Chapter 6. Chapter 6 was just the incremental IRR, like, but different for two mutually
Oh,
exclusive
right.
projects.
And like we have to subtract the 2. Oh, right. Okay, that
Right.
one.
Yeah.
Yeah.
Yeah, something like this.
Oh, yeah.
Where is B minus A? This one. Find out if it's non-simple, simple, and you do that.
Cool.
That's pretty much it for all the chapters, I guess.
Yeah, I think you're done.
Anyone got any questions for any of the chapters?
Guess not.
Right then. I
I'll
guess
just
that
start the
will be
recording.